Hello, good evening. My name is Yogendra Kumar. I'm a maths teacher at AskIITians. Okay, today we are going to do lecture number 2 on probability. So this chapter, as we discussed before also, it comes for 4 marks in your board exam. So that's why you have to do this chapter properly. It is pretty simple. Okay, not that difficult. Okay, so I think you can score full marks in this chapter, right? Let's get started, guys. So these are the topics we are going to cover today. Complement of an event, problems on coins, dice problems, card problems, right? These all problems related to dice, cards, these problems we are going to discuss today, right? So what is complement of an event? If if we say occurrence of an event, then non-occurrence of an event is called as complement of an event, right? We can represent complement of an event by these ways, by following ways. Means I can write down P of A complement like this. I can write down, if there is an event E, there is an event A, then it's C here, that represents what? Its complement. Or we can write P of A bar also like this also, it is what we can represent, right? So these both, okay, this will be what? Complement. And you have to remember that P of A complement or P of A bar is nothing but 1 minus P of A. Now how does it how do we get this? Okay, let's prove that. Okay, but this is what you can see. This S here, this bigger box, rectangular box, represents what? Full sample space for us, right? And what is this event A, right? This circle here, it represents event A. So apart from this A, everything in this rectangular box, okay, that is what A complement, that is what complement of our event. I hope you're understanding this. This is how we say complement in these sets. Now what we are going to see here, how do we get this formula? By the way, 1 minus P of A. Let's do the proof of this. Okay, you will understand this. Okay, it is pretty easy, right? So we can this is whatever I explain, okay, that is what they're writing for any event E1. E1 is like subscript here, E1 here, like this we should write it. Okay, E and then 1. One second. So E1, okay, E and then 1 subscript. There exists another event E1 dash, which represents the remaining elements of the sample space, right? So here, if we write, okay, this is what E1 is equals to S minus E1 complement prime. Okay, we can write down like this also, A P of A prime. Okay, like this here. So it is what? S minus E1. Like this also it can be represented. So for example, if we say a dice is rolled, then the sample space will be this. If event E1 represents all the outcomes which are greater than 4, so this is what E1, and E1 dash is what? E1 complement or E1 prime. Okay, we say 1, 2, 3, 4, and all the other elements except these two elements right here. So this is what we write here, complement. Thus E1 is the complement of any event, right? Complement means what? U minus A. So now if we need to understand the probability here, right? So we can write n of A complement, number of elements in the A complement will be what? Number of elements in S minus number of elements in E in that event, right? You can understand this, number of elements in that event, right? I hope you are understanding this, because we are saying what here? In full sample space we have total elements, means the elements which are belonging to that. You can relate to this example. Now if I divide both side by n of S, what we get? We have seen this in the first lecture. This represent P of A complement or A prime, and this is what? N of S divided by n of S minus n of A divided by n of S. So this is what? 1, and this is what? P of A. So P of A prime is equals to this. This is how we get the probability relation here, right? I hope you got it. So now this question, throw two dice, what is the probability of the scores are different? Different means they don't want 1-1, they don't want 2-2, they want they don't want 3-3, they don't want 4-4, they don't want 5-5, and they don't want 6-6, right? So see, I'm looking for the probability for score of different, but if score is same on both the this one, both the dice, so this is basically E prime, opposite of what we want to find out. Now listing this is easier here because writing different scores will be 30 total outcomes. You can see, right? Number of elements in the sample space will be what, 6 into 6, which is what, 36, right? So now we can say like P of E prime here, because we are looking for what, this one, this E prime is what here, 6 divided by 36, which is what, 1 by 6. But we are looking for, okay, E represents what? E is what? Scores are different, right? Scores are different. So P of E is going to be what here? Tell me. 1 minus 1 by 6, which is what? I can say 5 by 6 it is going to be. I hope you got it, 5 by 6. This is what we are getting, right? P of E is what? Probability that two scores will be different is what? 5 by 6 we are getting here. So this is how we do, right? I hope you're understanding this, that this is what we are understanding, that total cases are this. So this is what probability is what? I hope you got it. Okay, you can do it directly also. Different scores will be what? Different scores will be what? 30 divided by total number of scores are what? Like total cases will be what? 36. So you can see like this also, 6 5s are 6 6 are, right? 5 by 6 like this also. This is what answer we give here. I hope you got it. Okay, please ignore this. They have done some mistake. Okay, I hope you got what I'm trying to say, right? You got the idea. Okay, let's see the next thing. Problems on coins. Okay, probability of an event E is equals to number of favorable outcomes divided by total possible outcomes. When two coins are tossed, possible outcomes will be what? H H T T H T T H. Thus the total number of possible outcomes will be what? 4 here, right? When three coins are tossed, you need to remember, right, how many cases will be there. You can say like three coins means on first coin two possibilities, and on second coin two possibilities, and this. So this is how we can give 8, right? You can see here. So when two coins are there, 2 into 2. When two dice means what? 6. On first dice I have 6 possibilities, and on second, and means what? Multiplication, you need to remember, right? 36. If three dice, total cases will be what? 6 into 6 into 6, which is what? 216 we are getting, right? So this is how we get the total number of cases. Let's see more questions here. Three fair coins are tossed simultaneously. What is the probability of getting at least two tails, right? So if I write the full sample space, I'm going to get H H H, then H H T, then H H. Okay, H H I have written, so let me change here. H T H. It will be HTH, next HTT, next it will be THH, THT, right? THT, then TTH, and Okay, I wrote TTT first, so TTH, last case TTH, right? So you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 are total cases, right? Because 3 coins means what? You need to remember 2 cases on first coin, then and 2 cases on second, and 2 cases on third. Okay, so that's why 8 cases here, like this, right? 2 tails. So this is what it is. Now they're telling at least, remember here the word, okay, you need to underline at least 2 tails. So at least 2 tails, which cases we have here? You can understand at least 2 tails. This is there, this is there, this is there, this is there. 2 tails we want. At least 2 tails means what? So probability will be what here? Okay, if I write the probability P of E. Okay, let me write down E also first here. So we can have H, T, 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 H, T, 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 H. Okay, we got this. Okay, H, T, 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 H, and T, H, T. Now what else I can have? H went to, okay, this case. This is the last case. At least, right? So probability of E will be what? 4 divided by 8, which is 1 by 2. This is what we're getting the answer, right? I hope you understand this, right? Number of 4 divided by 8, like this. This is what the solution here also it is given, right? You can follow this also to get the more details. Right, now problems on dice. Okay, we have 2 dice are rolled. Let A, B, C be the events of getting sum 2. So A is what event? A is what? Getting sum 2. B is what? Getting sum 3. C is what? Getting sum 4. Right, this is what. Then show that A is a simple event. Right, we need to show that A is a simple event. Now, what is the definition of simple event? You need to understand simple event are those events which has one of the outcome from this total sample space, right? We are rolling 2 dice, right? So sample space is going to be what? Let me write down the sample space. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like this. Then we start with 2, 1. And like this we'll keep on writing till 2, 6. Right, after that we'll continue till 6, 1, 6, 2, and then last will be 6, 6, right? Like this. So this is what total sample space will be this. So you can understand like how many elements will be there in this. N of S are going to be 6 into 6, which is what? 36, right? This is what we have here, right? Now what is the sample event from here? Sample event is what? A is the samples. We are showing here that sample event is what? Only one outcome should be there, right? One of the outcome from here is called as sample event. Only outcome from sample space. Okay, so as you can see, 2 is possible by this event only, right? So A is having, A is what? 1, 1 only. This is what it is. So it is what? It is having just one outcome. So that's why it is what? Simple event. I hope you got the idea, right? This is what the answer. Now what is now B and C are compound events. Okay, sum is 3. So B event is gonna be sum is 3, 1, 2, and 2, 1. This is what are B. What is C? C is what? Sum is what? 4. So 1, 3, then 2, 2, 3, 1. So you can see there are more than one outcomes. So that's why B and C are what? Compound events, right? you can say these are what compound events. If we get more than one outcomes from the two things here, right? So these are compound events. Now A and B are mutually exclusive. Now what is the definition of mutually exclusive? If two events prevents the occurrence of one another, if two events prevents the occurrence of one another, or there is no intersection, there is nothing common in them, right? If the two events are not they are not having anything common, so A and B are mutually exclusive, because if A is happening, B will not happen, and if B is happening, A will not happen, right? So A and B are mutually exclusive here. So we proved all the cases, right? You can understand A intersection B is 5, so that's why mutually exclusive, right? The full sample space is given here, right? You can understand. I hope you got the idea. This is how we prove it. Okay, let's move to the next question. Two dice are thrown. The odds in favor of getting the sum 5 and odds against the getting the sum, right? So we need to do this. Now what is the definition of what, how do we prove odds in favor and odds against, right? We need to understand this. So two dice are thrown, so odds in favor of getting sum as what? 5. So if you see probability of, if you, now we need to count the cases which are in favor of us and which are not in favor, right? That is what odds in favor. So first part, if you see here, odds in favor of getting sum 5, right? So what are the odds in favor of getting sum as 5? So if suppose I say E is an event of getting sum as 5, sum as 5, so E will be what? Sample space will be what? 1 comma 4, then 2 comma 3, then 3 comma 2, then 4 comma 1. These are what, like this we have, right? Odds in favor, sorry, odds, these this is what, these are event E. Now these are the cases we have which are in favor of us, which are the favorable cases, right? We have. So now how many total cases are there? Total cases n of s is equals to what I can say? 36, because two dice are there. N of E is what? Here we have how many? 4 cases only. So now odds in favor. Odds in favor will be what? 4 divided by not cases not in favor, right? So that's why it will be what? 32. So we can simplify, it is what? 1 by 8. We can give the answer like this, right? So this is what odds in favor, 1 divided by 8. I hope you got it. Odds in favor, 1 divided by 8. You can see more details here, right? Now for second part, we can see odds against getting sum as 6. So sum as 6 will be what? How can we get it? Okay, 1 5, then 2 4, then 3 3, then 4 2, and 5 1. So these are the cases 5. So odds against they are asking, right? So means not favor cases, right? Not in favor cases, how many will be there? How many cases will be there? You can see like 5 are listed here. So 31 divided by 5, simple, right? You can see the answer here. I hope you got it. We need to write above. Now this time we need to write the not favorable cases and divided by total cases. This is how you need to understand. You can remember this thing like this also, that probability of happening of first event divided by, you can understand P of E divided by P of not happening of E. You can remember like this also, P of E divided by P of E prime, or like this. Okay, so 4 divided by 36 divided by 32 divided by 36, which is what? 4 by 32. So it is indirectly 1 by 8 only, right? This is what it is. You can remember, you can understand this, right? I hope you got the point. This is how we do odds in favor, odds against, right? If odds in favor are given, we can find out the probability also, right? So you should not be confused with this. Now problems on cards, you need to remember this. You need to understand the cards first. 52 playing cards. We are talking about the cards which we use, right, in playing, not the special cards we are talking about. We don't include the jokers here, right? 4 suits, 13 cards. Okay, 13, 4 suits are there. Heart, diamonds, clubs, and spades. Okay, like this. Cards of spade and club are black cards, right? Cards of heart and diamonds are red cards. The card in each suit are ace, king, queen, jack, or knaves. Okay, like this here. These are all called as knaves, which are 2 to 10, like this here, right? You need to remember 12 cards. These king, jack, queen are called as face cards. You need to remember. Ace we don't include in the face cards. Remember that. So let's see now this question based on the cards. A card is drawn from the well shuffled pack of 52 cards. Find the probability of 2 of spade. So 2 of spade is single card. So that's why 1 divided by 52. I hope you got it right. Simple answer. A jack are 4 cards. So 4 divided by 52, which is what? 1 by 13, right? This is what these are the answers. I hope you got it. Pretty simple question. You need to practice more questions to get the complete hold of this topic, right? A card is drawn from well shuffled pack of 52 cards. Find the probability of neither a spade nor a jack. Okay, we don't want spade or we don't want jack, right? It should not be spade or jack. Okay, so now you need to understand this. Okay, now you can pause and try this question yourself. I hope you're getting it right. Okay, so let's understand now. Neither spade, we don't want spade. Spade are what? 26. And in those, okay, spade in those, in spade one, sorry, spade are 13, my bad. 1 second. Yeah, 13 spade are there. And there is a jack, which is what? 13 spade, including 1 jack of spade, right? 1 jack of spade, like that it is there. Nor a jack, right? So how many remaining jacks are there? 3 other jack, other suit jack, right? So total cards which we don't want, right? We don't want. So how many are there? 16, right? 16 are those cards. So these are the cards we don't want. We don't want. So how many cards are remaining? So the cards which we want will be what? 52 minus 16. So what are we getting? 6 here, right? And then 4 here, so 3, 36. So probability is what? 36 divided by 52. So 4 nines are and 4 13. So 9 divided by 13 should be our answer. I hope you got it right. So we can do this way. Right now there are practice questions which you should try yourself. Take your time. You should not look at the solution. You should try these all questions yourself. Okay, and refer the solutions later, right? Let me do the first question for you. 2 fair coins are tossed simultaneously. What is the probability of getting one, only one head, right? We want one head only. So full sample space is what? S is equals to head, 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 tail, tail, head, tail, tail. One head only are 2 cases. So probability will be what? 2 divided by 4, 1 by 2, right? I hope you got it. I'm writing it directly. 2 dice are rolled. A, okay. If you want, I'll show this. Only one head means what? It should be HT or TH only, right? We want only one head. If it was at least one head, right? At least one head, then we will include this case also, HH also here, but we want this only, right? So I hope you got it. Now 2 dice are rolled. A is the event that sum of the numbers shown on the two dice is 5. So first question is done. Now let me do next question. Okay, two dice are rolled. A is an event that 5. We want sum as 5. So 1, 4, 2, 3, 3, 2, and 4, 1. Like this we want, right? Now B is an event that at least one of the dice shows 3. At least one of the dice shows up a 3. So B is what? One of the dice. So 3. Now 3, 1. It could be there 3. Right? Are you understanding? 3, 2, 3, 3, 3, 4. Okay. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Now another die can show the 3, right? So 1, 3, 1, 3 it could be there, right? There is no problem. 2, 3 it could be there. Now 3, 3 we listed already, right? So we'll not write it again, right? So 3, 4, 3, 5, 3, 6, right? This is what we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n of B we have 11. N of A we have how many? 4. N of B 11. N of A is what? 4. Now they're telling, okay, fine. Are the two events mutually exclusive? Are these two mutually exclusive? Means occurrence of one. Do they have any intersection? A intersection B is what? A intersection B is not 5. So they are not mutually exclusive. Are they exhaustive? Exhaustive means what? When we combine them, are they making full sample space? No, they are not making full sample space, so they are not exhaustive. Give arguments to support your answer, right? I hope you got it. Not mutually exclusive, not mutually exclusive, not exhaustive, right? Why? Because when you do the intersection, they are not giving there is it's not 5, it is what? Something common, right? When we do the union, they're giving, union of them is not giving full sample space. Okay, a card is drawn from a, okay, next question. Now a card is drawn from a well shuffled pack of 52 cards. Find the probability of neither heart nor a king, right? I think nor a red king. We have seen this type of question before. I hope you can attempt it, right? Okay, try it. Solutions are provided, answers are provided, right? Got it? Okay, fine. I hope you understand. Okay, thank you very much for your time. See you in the next lecture. Okay, bye bye.